Welcome to Lead Electrical Academy. So today we will see the three-phase semi-converter with DC series motor. So this is three-phase semi-converter, which is fed from DC series motor. So as this is circuit consists of three phase input voltage VA, VB and VC, which is connected to thyristors. This is known as upper leg connection. So upper leg connection consists of three thyristors. This is upper leg connection. So upper leg connection consists of three thyristors, thyristor T1, T2 and T3, and lower leg connection. This is of lower leg connection. Lower leg connection consists of three diodes, D1 as well as D2 and D3. These are three diodes, which is also connected in parallel with freewheeling diode. So this is the freewheeling diode, and which is connected in parallel with RA and RF. RA is known as armature resistance, and RF is known as field resistance, and LA is known as armature inductance, and E is the motor back EMF. So this is about the three-phase semi-converter circuit. So we will see the operation. So first, in a cycle of source voltage, we will consider thyristor T1 receives a gate pulse. Thyristor T1 receives a gate pulse and conducts for 30 degrees to 150 degrees. So thyristor T1 will receives gate pulse and conducts from 30 degrees to 150 degrees, and thyristor T2 will conduct from 150 to 270 degrees, and T3 will conduct from 270 degrees to 390 degrees. So for both continuous and discontinuous mode, these are the thyristor connections. Conduction time period. So we will see one by one. So for a firing angle, the alpha value is 0. So thyristor T1, T2 and T3 would behave as a diodes. In semi-converter, for alpha equal to 0 degrees, thyristor T1, T2, T3 would behave as diodes. And the voltage of semi-converter would be 6 pulse or symmetrical 6 pulse for the cycle. So it is represented here. I will show the diagram. So this is the diagram. For alpha equal to 0 degrees, thyristor T1, T2, T3 will conduct, and this is known as symmetrical 6 pulse cycle. Okay, this is the symmetrical 6 pulse cycle. For this is the output voltage waveform for alpha equal to 0 degrees. So this is the conduction time period. Okay. Next, for would be a 6 pulse for a cycle, and the output voltage consists of VAB, VAC, VCB or VBC. This will be continuous. So the output voltages will be varied from VAB, VBC and VCA, and the triggering angles, of thyristors T1, T2, T3 would be delayed, but the return diodes, as we consider the three diodes, no, the return diodes D1, D2, D3 remain unaffected in the alpha equal to 0 degrees. Remain unaffected. So the pulses can be altered. Altered means they can be changed, and the load current will be continuous. The load current would be continuous, and a little ripple will be considered. So I will show the diagram of the waveforms of voltage and current. So this is for alpha equal to 0 degrees. We have triggered a T1. T1 will conduct from, as we considered, it is conducting from 30 degrees to 150 degrees. After that T2 will conduct from 150 degrees to 270 degrees, and T3 will conduct from 270 degrees to 390 degrees. Again the thyristor T1 will continues to conduct. So this is the alpha equal to 0 degrees waveform. So it is shown. So positive group and negative group. For positive group, the T1 and T2 and T3 will conduct. For negative group, D1, D2, D3 will conduct. And the current, if you observe here, the current will be continuous throughout the working range. So the continuous current will be present. So this is about alpha equal to 0 degrees. Next we will move on to next alpha equal to 60 degrees. When alpha equal to 60 degrees, the conduction in positive group, first subscript indicates the positive group. So first subscript indicates positive group element. So as you know, positive group elements are thyristors. So and second subscript indicates negative group elements. So VCB indicates T3 is already conducting. So we will take diode D2 in the negative group. Negative group. So here voltage for VCB it is shown. So we will see in the diagram. So for VCB, if you observe, T3 is conducting. Already T3 is conducting. So it is conducting from alpha equal to 60 degrees. And in the negative group, we will consider the diode D2. So T3 and D2 will conduct for 60 degrees. Next we will consider for VAC. So for VAC. So for VAC conduction, for VAB or VAC, the VAB, for VAB if we consider 120 degrees. So at omega t equal to 60 degrees and alpha equal to 30 degrees it will conduct, and T2 will conduct for 120 degrees, and for omega t equal to 180 degrees and alpha equal to 30 degrees. So this is the conduction. So the thyristor T2 will be triggered for omega t equal to 300 degrees also. Omega t equal to 300 degrees also it is triggered, and next after the T2, T3 will conduct. T3 will conduct. So this is the waveform. So if you observe in the waveforms, so first T3 and D2 is conducting, next the T1 and D3 will conduct, next T2 and D1. This will continue to conduction for the voltage VCB and VAC and VBA. Again after the cycle VCB will repeat, VCB again VAC and VBA. This will be repeated for alpha equal to 60 degrees. Next for 90 degrees, firstly freewheeling diode action will be takes place for 90 degrees. After that T3 and D2 will conduct. If you observe here at 90 degrees T3 and D2 will conduct. After 90 degrees freewheeling diode action, and after the T3 degrees T1 will conduct. So if you observe, first T3 and D2 will conduct, next T1 and D3, again freewheeling diode action will continue, again T2 and D1 will conduct. After this the cycle will repeat again for 90 degrees. So if you observe, the current waveform will be continuous for 90 degrees also. At 60 degrees it is continuous, at 90 degrees also the load current will be continuous. If you take the 120 degrees, at 120 degrees the back EMF will be represented. After the back EMF the VCB will continues, and here also VAC and back EMF and VBA will be represented at alpha equal to 120 degrees. The load current will be continuous also here. The load current will be continuous throughout the working range. So this is for firing angle 120 degrees also the load current is assumed to be the somewhat discontinuous. So here the load current will be discontinuous for 120 degrees. For each period cycle 120 degrees, V0 is seen to have three components. When SCR is gated, the thyristor and diode will conduct for 60 degrees, and the V0 reaches 0 and tends to be negative. So here the V0 will be reaches to 0 and tends to be negative. So the freewheeling diodes get conducted and holds the load voltage to 0. So all the energy stored in the inductance can be discharged through freewheeling diode. So it can be stopped. As a result, the load voltage rises to counter EMF EB. Here the voltage can be raised. So this is the voltage. So this can be raised to back EMF, and V0 equal to EB here. So at 120 degrees V0 equal to EB here, and it is indicated at 0, 0. So here it is indicated. This is the 120 degrees, the load current will be discontinuous. Up to 120 degrees the load current will be continuous only, but at 120 degrees due to the diode conduction the voltage can be 0 and tends to be negative. So here freewheeling diode action can be takes place. Due to the freewheeling diode action it holds the load voltage to be 0. So all the energy stored in the inductance can be discharged through the freewheeling diode and it stops conducting. So the load current can be discontinuous in the 120 degrees mode. Next we will see the current wave speed torque characteristics. So these are the speed torque characteristics. As it is the DC series motor, it will exhibit inverse hyperbola characteristics. Inverse hyperbola characteristics for DC series motor. Next we will see the average voltage and currents. So the average average terminal voltage is known as V naught at an angle alpha is equal to 3 by 2 pi the firing angle, or we are considering the boundary conditions from 30 alpha to 150 plus alpha, and Va minus Vc, the voltage at d omega t. So this is the average voltage. So for this, the condition, as we have to apply KVL, no? So RA Ia is the voltage drop across resistance, and KAF into Ia, KF into Ia into speed, and plus K resultant into speed, that is equal to V naught at an angle alpha, that is equal to 3 by 3 root 6 Vs by 2 pi into 1 plus cos alpha. This we will derive in the next class. Thank you guys, we will meet in next class.